Hello student, in this video we are going to discuss about the formulation of simple regression, and here I am Dr. Amjad Ali, and I have tried to make the derivation more easy, as I have found that number of students have not enough strong mathematical background. So I hope you will enjoy and learn uh, about your targeted things. Okay, before the formulation, let's see one definition of the principle of least square. Okay, the principle of least square, LS, consists of determining the values for the unknown parameter that will minimize the sum of squares of the error or residual, where errors are defined as the difference between the observed values and the corresponding values predicted or estimated by the fitted model equation. So this means that the error is equal to observed or actual minus predicted or estimated value. We have given the simple formula for the error in the introductory or statistical section of the regression video. So this means that the error, which is technically called the unexplained variation, error is equal to observed actual or true value minus estimated value. Okay, the parameters values thus determined will give the least sum of square of residual or errors and are known as the least square estimates or minimization of sum of square deviation. So keep it in mind that every regression or the principle of least square, every type of regression, the main aim of every regression is to minimize the sum of the square of the residual. So you know you will learn in the practical session that how can you calculate the residual sum of square in coming videos. Okay, least square estimates in simple regression. Let we have a two variable. Let's say we have a xi, yi, and you know the meaning of the subscript I. This means the number of observation 1, 2, 3, so on, n. And here we have a dependent variable yi and independent variable xi. So we can say that the xi are the fixed or predetermined values and yi are the observation randomly drawn from a population. So the observed yi may be expressed in the linear form of population parameters as. So in case of population, as we have gone through the last video, that yi is equal to alpha plus beta xi plus ei. Here alpha and beta are the parameters and xi independent variable and yi is dependent variable and ei is the residual or error term. Okay, for the sample case, we have yi is equal to a plus b xi plus ui. So only difference between the population and the sample is here we are using intercept or slope as a and b. Okay, where a and b and alpha and beta are the parameter of the regression line. We actually have find such pair of alpha and beta which have capacity to minimize our residual sum of square. Okay, the best regression line is the one which minimizes the sum of the squares of the vector deviation between the observed yi and the corresponding values of the predicted by the regression line yi hat is equal to alpha plus beta xi. So if you have a data of xi and yi, and then you estimate alpha and beta parameters, and then after estimating the alpha and beta parameters, you can read it y hat y hat is equal to alpha a plus bxi. So in coming session, especially in case of econometric point of view, we use alpha and beta as a parameter. So sometime with the regular practice which I have made in econometric, I read it alpha and beta, so I think you don't bother it. But here for the sample case we have written a and b. Okay, so what is our error term? Error term I is equal to yi minus y hat. This is our estimated y. This is our estimated y, and here yi is our actual or true y. So when you subtract actual minus estimated, you got it as a ui is error term. So we can write it that the combination of our parameters, we are going to find such combination of parameters alpha a and b, ui is equal to, this mean when you are reading it of yi, so what is the value of yi hat? So here a plus bxi is the value of the y hat, so we put it a minus bxi, because here we have a sign of minus, so that's why the when you put the values of y hat, then all the values of the y hat become in the form of minus. So we get it ui is equal to yi minus a minus bxi. Okay, including the sigma for the equation. When you are using a sigma, putting a sigma on the both sides, it means that we have ui. So sum of ui is started from I to ranges n. So like that we have a sigma for the yi minus a minus bxi. So it started from I, started from 1 to n. Okay, taking the square root of the both side, when you take the square root of the both side, then this equation become this. So this equation become this. You are taking the square root of this equation, and this equation will become as u square I is equal to yi minus a minus b xi. It is repeated here, but here this is the square of this equation. Okay, this is known as residual sum of square. So this is our ultimate objective in coming session, that we have to minimize this value as much minimum residual sum of square as best fit regression line we will find in or this will be a good fit our model. Okay, here you can see that we have a x-axis. It is known as x-axis, x1, x2, x3, x4. Here we have a y-axis, and here if we have the x1 value, and here we have a y1 value. So this means we can draw a line like that, but in regression case we have no no need to draw such graph which will meet the values of x and y. We are normally using a scatter diagram in the regression case. Okay, we have a x2 and y2. It means we have x2 and y2 here. Okay, we have a x3 and y3, and here we have a x4 and y4. This is the combination of x4 and y4. Okay, the main aim of here, we have to draw a straight line. Okay, we have drawn a straight line. So see here y1, y2 and y3 are more close to the straight line, or estimated. So technically this is called the estimated regression line. Y hat I is equal to a plus bxi. So this is our estimated line. So here we have a 4 values. So 1, 2, 3, 4. So 3 are very close to the straight line. So this says that we can use a regression analysis for for this particular model, for this particular model. Okay, what you mean by the part which is under the estimated line, and what you mean by this part which is over the straight line, or you can say that what you mean by the difference of this and this, or this and this, or this and this, or it's little, or this and this. So let's discuss the difference between, this is your estimated, so keep it in mind, this is your estimated and this is your actual. So this is what you mean by this difference and what you mean by this difference. So this difference is estimated a plus b xi. So this is actually we have estimated, but this part we are not covering. So this is our unexplained variation. This is our error. Ui is equal to a minus b, a minus b xi. So see what we have generated here. We have generated error here. So here you can see that this is your estimated part and this is your unexplained or remaining part. So this is our complete analysis, but we have missed the unexplained variation. This is your explained variation technically, and this is your unexplained variation. I hope you catch it. Okay, after this we are going to draw the formulation of A and B, because it's our ultimate objective. We have to find such combination of A and B which minimize the residual sum of squares. See here, if this part is higher, this part is higher, then this part will be lower. So when this part is lower, then square root of this part will be lower or minimized. So we have to find A and B, such combination which will increase our explained variation. So let's start. The basic aim of A and B is to minimize the residual sum of square. Okay, we have the residual sum of square formula, summation I is equal to 1. So this means that residual series observation start 1 till n, and u square I is equal to. So this means that this equation will start from 1 to till n. So this is the formula for the residual sum of square. Here taking the partial derivative with respect to A and B and putting equal to 0. So when you take the partial derivative with respect to A and B, then this will come. So see, if you are very well aware about the formula for the partial derivative, then you know that we in partial derivative we take the power and then we reduce the 1 from the power, and then it will become a 1, and then we take the derivative of this whole thing, and this will become 0 and this will become a 0 because we are taking the derivative of 1 A with respect to A. So that this will, when you take the derivative of A divided by A, then answer will become -1. And when you are taking the derivative with respect to x, so power, we write it power, and power after that we reduce 1 from the power and then become this, and we have to take the derivative of the remaining part. This will become 0, this will become 0, and this will become -xi because we are taking a derivative with respect to b. So here we have a x. Okay, we have a xi here. Okay, solving these equations, we are going to solve these equations. Let's start. If you are solving this equation, then this 2 will be divided by this side and then it will become 0, and this will be 2 divided by this side, it will become 0 because we are solving this part of equation. So that's why I have written this part of equation. So 2 will be removed because 2 will be divided by this side is vanished. So our equation will become this. So next we have to multiply -1 by the whole equation, and here we have to multiply by xi the whole equation, and then we get, see, minus y plus before the multiplication of -1 it was a minus, so minus minus plus, and here we have a minus plus bxi is equal to 0, and on that side we have multiplied minus xi. So here I missed xi, so you can write it minus xi. So when you multiply the xi, it becomes xi, yi is in the form of minus, but here we have a minus a. So when minus multiply with minus, it will become a plus axi and plus bxb. Here b square I. So here we is solving it for a summation. So let's solve the equation for a summation. So see here if you take the if you multiply the whole series with the summation, then minus xi, we take the minus xi on the other side of the equal, then it will become a plus xi and is equal to na. When you are multiplying the constant with summation, then we normally write it in the form of n, number of observation. So our summation is also sum of observation. You are very well aware in the first or second chapter of the stats. Okay, here we have an a plus, here we have b. When you are giving the summation, and summation is not, I told you that summation is used for the variable point of view, so that's why our summation is multiplied by xi. So on that side we have divided by multiplied by summation this part. So after multiplying summation this part, this negative value taken to the right side, or you can say it on the other side of the equal, this become a positive, and we can write it as. And when we multiply the summation by this, then a summation xi plus b summation xi square. Okay, these two equations are solved simultaneously for getting the values of a and b either by using direct elimination or by using the determinants method. Elimination method, direct elimination method, we have to subtract this equation from this or this equation from this, and then we get the alpha and beta value from this method. And the other determinants method, we have to use the matrix algebra for solving or for getting the values of a and b, because our target to find the formula for the a and b. Okay, see, with the help of direct method, multiply first equation by summation xi and the second equation by n, and remove the subscript, because here we are removing the subscript for the easiness, because if subscript is available, then the estimation procedure will be more complex. So that's why we are removing the subscript sign here. Okay, we have multiplied the first equation by summation xi. So before that it is summation y. So here we have summation x, summation y is equal to na summation x minus or plus b summation x square, because we are multiplying by summation x. So on the other side, the second equation we are multiplying by n summation xy is equal to na summation x plus nb summation x square. Okay, now subtract this equation from this equation from this, keep it in mind, this equation from this, and we get this. We get when you are subtracting this equation from this, so see it, this will be minus and this will be plus. So these nax summation x will be cancelled out, and we have n summation x summation y minus summation x summation y. So this will and summation x summation y. So here I have used a wrong summation, so you can remove it for yourself. So it is n summation xy minus summation x summation y is equal to nb. So see, this is the nb summation x square minus this part will be remain minus b summation x square, and take b common from the right side. From the right side we are going to take b as a common, and then okay, here will be okay. After that, n summation x, I have told you that this is wrongly given, so you have to remove it. It is n summation xy, not summation is given here, minus summation x, because it will be correct in coming equation. That beta will be common here, so this will be okay. For solving it beta, we get this. So see here, I told you that this summation is wrongly placed here, so you can remove it. So here we have n summation xy minus summation x summation y divided by this part, because we are getting the value of beta, so this part will be divided. So we can get the formula for the beta. We can write this formula as in this form as also. We can practically or empirically test these formulas in the coming videos. Okay, with the similar procedures, we can get the value of a is equal to n summation x square summation y minus summation x summation xy divided by n summation x square minus summation x whole square. So denominator is same, but numerator will be a little bit different. Okay, another method for getting the value of a is equal to y bar. It's mean value of y minus b x bar, so mean value of x, and then after subtracting it we get the value of a. So normally student use this formula for getting the value of a, and for getting the value of b normally this will be used in coming empirical session, but this will also we try to prove in the empirical session. Okay, here the last one is the determinants method. With the help of methods we can find the determinant of a and b, and then we can divide the determinant of this part and this part, and you see that if you multiply by this and if you multiply by this and then multiply by this and this, we get this formula, and this is formula of b with the help of determinants method, and this is the formula for the a with the help of determinant method. You multiply by this, and we get this, and this is the formula of a and b with the help of determinant method. Okay, these estimate give us the estimated regression, which is our ultimate objective, that y hat is equal to a plus bx. Here keep it in mind that since y is a random variable, therefore the deviation in the y directions are taken into account in determining the best fitting line. So keep it in mind, we are finding such combination of a and b which will make our fitted regression line a best fit. So it is very important to note that when both x and y are observed at a random, the sample values are from a bivariate population. There are two regression equations, each obtained by choosing that a variable as a dependent variable whose values is estimated and treating the other variable as an independent. Here in this case we are taking xi as an independent variable and yi is as a dependent variable. Okay, in this case when you have one single independent variable and one single dependent variable, it is called a simple regression. And for multiple case formulation, I will give another video for you. But after the solution of our empirical testing of these estimated regression line, now in the coming video we will empirically find the estimated yi is equal to a plus bxi. I am using the word estimated. When you have a y hat, so technically our interpretation point of view, this is called the estimated yi is equal to a plus bxi. Okay, see you with the next video, which is based on empirical testing of the regression line.